The James Webb Space Telescope has just delivered some of the most astonishing data ever gathered from an alien world, Proxima Centauri b, a planet orbiting the closest star system to Earth. And with this new data comes an even bigger question. Could this world be more than just another rocky planet? Could it be something far more significant, a second Earth, or even a cradle of alien life? Proxima b is not just any exoplanet. It lies within the so-called habitable zone of its parent star, a red dwarf known as Proxima Centauri. This is the region around a star where temperatures may be just right for liquid water to exist, a key ingredient for life as we understand it. That alone makes Proxima b a major point of interest. But there's more. What makes Proxima b truly intriguing is not just its location, but the nature of the signals we've received from it. Astronomers have long debated its potential for habitability. But now, thanks to Webb's powerful infrared eyes, we may be closer than ever to answering that question. When the telescope focused on Proxima b, it detected a peculiar glow, an unusual and unexpectedly bright signal coming from the planet's night side. This glow is far more intense than what would normally be expected from a planet of its size and distance. It's not easily explained by natural processes like reflected starlight, volcanic activity, or atmospheric auroras. And this has led to some mind-bending speculation. Could the glow be artificial in origin? Could we be seeing signs of alien city lights, evidence of a technologically advanced civilization? It's a provocative idea, and scientists are treading carefully. There are natural phenomena that could account for unusual brightness, but this case is different. The intensity, consistency, and placement of the glow raise questions we're not yet equipped to fully answer. The James Webb Telescope is uniquely suited to detect such anomalies. Unlike previous space observatories, Webb operates primarily in the infrared spectrum, allowing it to pick up the faintest traces of heat and light from distant planets, even those orbiting dim stars like red dwarfs. This gives it a distinct advantage in studying exoplanets, especially ones as nearby as Proxima b. But the mystery deepens when we look at the planet's thermal signature. Normally, a rocky planet absorbs light from its star and emits infrared heat in predictable patterns. Proxima b, however, doesn't follow these patterns. Its heat distribution is uneven, suggesting that something is altering how heat moves across the planet's surface. One possible explanation is an atmosphere. If Proxima b has a thick atmosphere, it could distribute heat from the star-facing side to the dark side, reducing the extreme temperature swings that would otherwise make the planet uninhabitable. This would be a major find. A stable, heat-redistributing atmosphere might support liquid water, and possibly even life. To test this idea, astronomers are looking closely at the planet's atmospheric composition. They're searching for specific gases, like oxygen, methane, and water vapor, that might indicate biological processes. These gases, if found together in the right proportions, could be powerful biosignatures. Detecting oxygen is especially challenging. It's often masked by other chemical elements, and its presence alone doesn't prove life. But Webb has another advantage. It can detect ozone, a molecule that forms when oxygen interacts with ultraviolet light. Ozone could serve as a secondary indicator of biological activity. However, caution is essential. Some gases that are linked to life, like methane, can also be created by non-biological sources such as volcanic eruptions or chemical reactions on a barren surface. That's why multiple observations and independent confirmations are critical before making any claims about life. Still, the discoveries from Webb have ignited excitement among scientists and space enthusiasts alike. And Proxima b isn't the only world under the spotlight. Others, like Kepler 442b, a planet about 1.3 times the size of Earth orbiting a distant star, and the famous TRAPPIST-1 system with its 7 rocky worlds, are also potential hosts for life. 3 of TRAPPIST-1's planets orbit within the habitable zone and may even possess liquid water. Each of these worlds brings us a step closer to answering one of the biggest questions in science. Are we alone? The road ahead is thrilling. Ground-based giants like the Extremely Large Telescope, ELT, expected to begin operations in 2028, will offer even sharper views and new data. These next-generation observatories will help determine whether the atmospheres of these exoplanets contain life-friendly chemistry or something entirely unexpected. Meanwhile, Proxima b remains one of the most compelling targets. It's tidally locked, meaning one side always faces its star, basking in perpetual daylight, while the other is trapped in darkness. And it's constantly bombarded by intense solar winds and radiation from its star, which could strip away its atmosphere over time. Yet even under these harsh conditions, the potential for life remains. On Earth, life has proven remarkably resilient, thriving in boiling volcanic vents, frigid polar deserts, and even radioactive waste. If life exists on Proxima b, it may have evolved to survive conditions we'd consider extreme. As we peer deeper into the cosmos, the discoveries we're making are transforming speculation into science. The James Webb Space Telescope has opened a new era, one where the idea of other Earths, of life beyond our solar system, is no longer pure imagination. The universe is vast, and Proxima b is just the beginning. What we find next may redefine our place in the cosmos.